Hi, hello everyone. In today's lecture video, we will be covering the last phase of the requirements engineering phase, which is requirements validation. So if you remember, the requirements engineering process consists of four different main phases. The first of which is requirement solicitation, followed by analysis and specification, which tend to go hand in hand, and then they're followed by requirements validation. And the whole point behind requirements validation is to check for a number of things. First of all, did we understand the requirements right? Do we have a common understanding with our customer? Is this really what the customer wants and needs? But sometimes also requirements validation is there for the design team to give us some input on, do we have the technology to be able to do this? Do we have the resources to be able to do this? Is there any requirements that are conflicting? Okay, any of these requirements, do they seem inconsistent, or incomplete or incorrect, and so on? And in the requirements validation phase, now remember, before we get into more details, I want to just stop here and just say it's called requirements validation, not verification. I know the two words sound very similar to you right now, and in your fourth year course, SE 412, software testing and quality assurance, you'll get to understand the main differences between those two words. But the word validation, it comes from the word valid, is to make sure that this is a number is even within the realm of what it could be acceptable as a piece of information. For example, I can ask somebody, what's the temperature outside right now? And they'll say 25 degrees Celsius. Well, 25, that's a logical number. Okay, I mean, that's a valid number. It could have been 23, so it could have been wrong, but at least it's still valid. Now, if I told you that the temperature outside is ABC, now ABC is not even a temperature reading to begin with. Okay, so ABC is not even a valid piece of information when it comes to temperature reading. So requirements validation is basically we're asking ourselves, did we even get the requirements right? Okay. Now verification is the opposite. Verification is to say, now that we understood it correctly, are we actually building the system correctly? Did we build it correctly? Okay. So what we do, for example, with the temperature thing, you will say something like, can we then verify that it's 25 degrees? So somebody would go outside or maybe look up on the internet and say, oh yes, okay, yeah, I can see it says 25, so it's verified. All right. And within the requirements validation phase, we're going to look at three different types of validation techniques. The first of which is called prototyping. You've been doing a little bit of this in the last lab with Azure. And we're going to also look at requirements inspection and as well as acceptance testing. We're going to cover requirements inspection in this course, but also we're going to cover it again in your SE 412 2 years from now. Also, but acceptance testing is one of those we're going to skim over in this course, but it's going to be a big chapter when you get to SE 412, when you get to your acceptance testing. When it comes to the software testing and quality assurance course, which is a fourth year course. Okay, so we'll begin with the first one, which is prototyping. And so prototyping, the whole point of it is to create a prototype, which is basically we're going to create an initial version of what the system does. Okay, so a very simple working system. Now prototypes can come in many different flavors. Could be something as simple as just a little picture being drawn, nothing you can click on, nothing you can open or minimize or anything like this. Just a little picture, at least giving you the layout of my my interface. It also can show, for example, what are the flavor of the functionality that's being performed, and it's a ballpark thing. Kind of get to have an understanding with a common understanding with my customer that this is actually what they want. Okay, some prototypes will be a little bit more advanced, kind of like the prototyping that you've done in your lab, where you can write, for example, a little bit of a script. So you enter a couple of numbers in one place, and then you click a button, and then it shows a third number somewhere else, and it's not really like doing the actual computation. It's programmed to show that number right away, the result. And again, it's the purpose of the prototype is not to implement this requested functionality, but kind of like to show another person, this is what is going to expect it to be the final product. So are we in the same ballpark here, or are we completely off here? Okay, so the prototype will be used to help with the elicitation and validation of our requirements. Gonna explore different options about the UI, maybe the colors, the sizes of the buttons and the text fields and so on, the look and feel, the layout, um, and also in the testing process to run back-to-back tests. Sometimes prototype is good that you want to just have a little interface that connects to a particular functionality that you have, and you just program that prototype through a bot to just keep feeding in that system with inputs and checking the outputs. All right. The benefits of using prototyping is, first of which, an improved system usability. This stems from the fact that we're getting feedback from our customer about the interface that we have. Okay, so you look at things, say, the customer could say, no, I want this button to be at the top. I want that button to be at the bottom. I don't want this to show on the same page. I want it maybe to show on the second page. Maybe the color should be this. Maybe the color should be that. And with this feedback, we're not actually dealing with the actual functionality per se of the software, but rather than just the HCI aspect, the human computer interaction aspect with that software, with the customer or even the end user presenting the ultimate user of the system, giving us their feedback as really what would make their life easier to use that system. Okay. Benefits of prototyping: if all goes well, we will end up with a closer match to what the user actually needs. And when we get the first two right, they kind of like play into the last three, which is it comes from the fact that if we really know, and if we have a stable set of requirements, a stable set of correct requirements, complete and consistent, my design is usually much better, which makes my maintainability much better, and my development effort a lot less. All right. So if you take another project, for example, a different project that the requirements that keep changing, and I keep designing and I keep hacking away on my design to keep changing it as well in order to be in accordance with the changing requirements, that design that I'm going to create is not going to be the best of quality. But if you give me a set of requirements in a project and you say, all right, that's it, that's exactly what we need, and it's never going to change, my design will be much better, which, like I said, will lead to improved maintainability, so I can make any changes in the future very easily. And also during the project, I would have a much reduced effort. So the phases of prototyping come in 4 steps. The first of which is I need to establish my objectives. Why is it that I'm going to be creating a prototype? Okay, and that usually comes in the sense that we want to set out to check our understanding of certain functionalities. So we got to outline what are these functionalities. Okay, and then when we outline the different functionalities, we develop the prototype for it. Okay, perhaps even an executable prototype. And then finally, we evaluate it with input from the customer, the designers, any stakeholders that are involved, and we get a report about the fitness of our prototype. We have two types of prototypes. What we call a throwaway. So after it serves its purpose of requirements validation, we tend to throw it away. The other one is called evolutionary. And the whole purpose of evolution is that after we create the prototype, we can say, all right, we don't want to waste our effort that we've created, we've put in using building that prototype. So might as well just keep working on it until the prototype itself becomes the final product. Okay, so we're going to look at the first one, which is a throwaway prototype. And again, they both have the same exact objective. Is that basically at the end, once we have come to an understanding of our requirements, all right, basically we just throw it out and we begin from scratch and we begin building the real thing. Okay, meanwhile evolutionary prototyping is, as advertised before, we start creating a prototype, but then we start to add more functionality as we go until we make the actual functionality. The prototype turns into the actual product itself, and then we finally deliver the system. So evolutionary prototyping used to be a big thing where you had to decide whether you throw away the prototype or you keep it, because back in the day, to create a strong prototype, one that actually has some executable functionality, it takes quite a bit of effort. So a lot of times you can spend like a whole month dedicated to creating a prototype, and people will say, since we've gone that far, why don't we just keep going with that prototype until we finish the whole thing, right? This might not be the issue anymore, because now there's a lot of rapid prototyping tool, much like the one that you actually used in the lab. And to be honest, I don't really have the statistics of how much evolution versus prototyping, throwaway prototyping is actually happening, right? But for the sake of it, both of them still exist. If you decide to go with the evolutionary approach, there's some advantages and disadvantages. The first of which, obviously, is since we're not throwing away our effort, we're gonna deliver faster, right? The look and feel will be a lot more closer to what you agreed with the customer, because it's the same actual product that you were showing to the customer in a prototype that is going to be the one that you're going to deliver ultimately. And with it, you can help the user commit to a particular design. The disadvantages of it is that it does require a bit of a specialist skill to create that. Okay, so you need a design team to do it. You can't have somebody with a business degree to do it, because it's quite a bit of significant programming that is required. And also maintenance of that prototype becomes not really the best, because you shouldn't be beginning the design of your system from the user interface down to the functionality. It should be the opposite, where you think about your functionality. So you set out on an architecture, then a high level design, then a low level design, and then at the end you decide on your user interface. Okay, so if you decide to go with the evolutionary approach, you don't end up with the best design quality, which then leads to maintenance becoming a bit of a nightmare at the end. And that's actually another reason why evolutionary prototyping is a bit more extinct now than maybe what it was years ago. Regardless of the approach that you take, the prototyping development may be based on rapid prototyping languages or tools, kind of like Axure that you actually been using in the lab. And when you create the prototype, it should actually focus on areas of my software or my requirements that I'm not really 100% sure I understand. I mean, if I really understand it very well, then what's the whole point of prototyping, unless I'm completely way off? But I should actually be directing my effort that I'm putting into prototyping to make sure and shed light on the areas that I'm actually not 100% sure. Okay, those prototypes, just for the sake of doing something that is quick and dirty, it's not gonna include a lot of the error checking material. Okay, like try and catch blocks and things like that, or even defensive programming techniques. They're not gonna be there, or even input sanitation, type checking. All of this, you're probably not gonna find this. What happens if the user enters junk information? Well, that's not gonna happen. It's just a prototype. So it would be lacking this sort of information. Also, it would be lacking any consideration for the demonstration of non-functional requirements. Okay, things like the probably usability would be the one thing that is considered in a prototype. But other than that, non-functional requirements, things like efficiency, maintainability, the use of a particular programming language, usually these sort of things, they're not really focused on, but rather the focus is mainly on the functional requirements. Okay, now the next technique we're going to look at is called software inspection. And basically software inspection is a checklist approach. Now, what checklist means is that you're really gonna end up with a checklist, really a bullet point, 1, 2, 3, 4, 5, 6, 7, and you're gonna look at a target document. You look at your checklist, and you're making sure that every that your target document, be it source code or whatever, doesn't have violations stated in the checklist. For example, in the checklist, it will say something like constant variables needs to be all in capital letters. So then you look at your code, your target document, and you check for all the constant variables that you have. And if one is not all capitals, then it would be a defect in the sense that it's violating the checklist. So you would write this down, you flag it down, saying that I find a violation in my, of the code. So in my code of the checklist, okay. Software inspection is not about correcting defects, but rather just checking any defects in a target document that was listed in my checklist. Okay, so things like different anomalies, like an uninitialized variable, certain non-compliance with certain standards. For example, like layout issues is usually a big issue, and in order to perform inspection, my team has to have some formal training. Okay, this is a very mechanical approach. Now, the whole point behind inspection, the premise behind it, is that despite that we're not actually fixing any errors, we're just calling out the defects that we found in our document that is violation of what's written in the checklist, is that the idea here is that those errors, those violations, tend to be symptoms of bigger problems. Okay, so if I have a variable that is not initialized, probably this is going to cause me an issue later on. If I have a constant that is not capital, maybe that's going to cause me a problem later on, because maybe somebody else in the project who didn't create that variable is starting to use it as though making that assumption as though that this is the variable that is going to be changing, but it's not changing, it's constant. Okay, so a lot of times the errors that we flag down, the defects that we flag down, tends to be symptoms of much bigger issues. In order to have an inspection process that is actually successful, we need three things. The first of which is the properness of the inspection list. In other words, how good is the checklist? Okay, how detailed is it? Is it actually looking for the different things that we should be looking for to begin with? So the quality of the checklist itself is a big deal. The second of which is the application of the checks. Okay, are we checking thoroughly when we're doing the inspection, or are we just doing it lazy and we're missing a lot of these checks? Okay, obviously, if we have a software tool doing those checks for us, it will help us quite a bit. The other thing is the diligence, okay, the experience and the knowledge of the people. Okay, so for example, I mean, let's just say I gave you a checklist, asking you to look for certain conditions, certain defects in for loops that exist all over our code, right? You know what a for loop is, but imagine if I give this to somebody who's never seen code before. They would have no idea what is a for loop. They would have no idea what is a constant variable. They probably won't even have an idea what is the variable to begin with, all right? So they could do the job, but they're not going to be doing as well as somebody like you who have a programming background, right? The target documents could be anything. It doesn't have to be code. Most of the time, like 95% of the literature and the reports are talking about inspection being performed on code, but it could be performed on anything, any artifact. Okay, software requirement specification document, any use case model, class diagram, to anything basic, anything that is a document, anything that is an artifact. I can create an inspection list for it, create a checklist for it, and then I do an inspection on it to make sure that it's not violating the checklist, okay, the items that are listed in the checklist. Okay, before I do an inspection, all right, I have some preconditions, certain things that have to be true before I can go ahead and do the inspection. First of all, the inspection list, the specification of it has to be precise. Okay, so if this thing that I'm asking somebody to look for and I'm actually saying it in a very vague way, right? They won't really have a good idea of, um, well, when I'm looking at this target document, is this really violating what my, my inspection list is saying, right? So, but if I'm really, really precise about what to look for, then, having a match or not a match is a more of a black and white thing versus, having unprecise or vague specifications. Okay. The team members that are going to be performing the inspection, they need to be familiar with my organization standards, because a lot of times these specifications that you see in a checklist come in from organizational standards. Okay, so you don't want to be teaching them the organization standards from the beginning, right? They should come knowing that already. If you're wondering, is this going to cost me money? Yes, it will cost you money, but the whole point is that despite the upfront cost, in the long game, we will be saving ourselves a lot of money, because see that little light blue line, which is the upfront cost, uh, the purple line showing the cost that we would have had having we not had inspection. So it's cheaper at the beginning, but then the errors that we found while doing the inspection will come back to haunt us, and now we're gonna have to fix it. So remember, an error is there whether we find it or not. Okay, and sooner or later it's gonna come back and say, well, here's an error, you gotta fix that one. So if you fix it during the coding phase or even the testing phase, it costs a lot more money than if you just fix it while you're still at the requirements phase. All right. So when we have the inspection process played out, there's people involved will play different roles, and the first role is the moderator, is the one who's control of the session. They tend to coach other people what's going on. They have some experience with facilitation. They gotta be also technically competent. Okay, not just anybody. Preferably somebody working on the project. Another person who's there is the coder, the implementer, or the owner of the document, the target document that we will be inspecting, should I say. And usually the owner is one of the most unhappy people in that meeting, but it's something that needs to be done. Then we have the people who are doing the inspection, our inspectors. Okay, we have a recorder. Could be the inspector themselves, could be somebody from the outside, or could be the moderator who is recording down any defects being found. So this is what a recorder is about. A reader, sometimes you'll have the inspection going as a group, so somebody would read out loud and then people would look at the same parts of the document at the same time. Or sometimes reading just happens by each inspector on their own pace, so they don't tend to read out loud in this case. So yeah, a lot of these roles could be sometimes played by the same people, but at least you'll have three different people. You have a moderator, you have the inspectors, and then obviously the code owner themselves. Okay, so the inspection process comes in, it has different phases: the overview, then in visual planning, the actual meeting happening in K, and then after we do the meeting, we decide on any rework, and if absolutely necessary, we can do another follow-up. Okay, so let's take a look at each one of these 5 different phases. So the first of which is called the overview, and it's kind of like saying, what is it we're expecting? We designate the team roles, how much time, why are we inspecting any particular artifact? So again, building up the motivation is a big deal into making sure that people are going to be doing their jobs correctly. Second step is the preparation. Okay, and it's usually done as a homework phase that has to be done before they come in. The inspectors come in. You got to be understanding the checklists. Understand not just what it means, but also be wary of, aware, should I say, of how to look for these things. Okay, maybe the rank and distribution of the error types. So this homework has to be done so that we don't actually waste time during the inspection meeting itself. Now, when we have the inspection meeting and the whole team is gathered, a reader is going to be chosen by the moderator, okay? And then the inspection starts to go through every single logic or branch of my code, and it is to find errors, not to look for if the person has written the code the way an inspector would have preferred it to be. So we're not really hunting for any specific solution, just looking for errors. And now when I'm saying errors, we're not looking even at syntax errors here. Again, errors in the sense that there is something in my target document that is violating my checklist. Okay, so all these violations are collected by the moderator, who creates a report at the end of the day, and then they give it back to the owner of that document. In case there's a significant amount of errors, it says 5% or more. It doesn't have to be a mathematical formula, but it's kind of like a hunch thing. It's got to be something that I use an intuition for, and I feel like, all right, this original document was really, really bad, then maybe we should do another inspection meeting, then go ahead for it. If not, then a follow-up is not really that necessary anymore. Okay, but rather that the follow-up could be in the form of just the moderator asking the author, did you actually fix the issues that were reported? And that's basically it. The third type of validation we're going to look at is acceptance testing. And we're going to really skim through it in this lecture because it's going to be a big part of your SE 412 course, the software testing and quality assurance course. Now, the software acceptance testing, it follows what we call the V model. And the V models, as you can see, the green line going down, then up again, creating the letter V. Okay, and the first half of that V model is basically your typical waterfall approach, which is requirements followed by design, all the way down to lower level design, and then all the way down to coding. And the whole point behind this is, as I'm doing the requirements and as I'm doing each one of those different steps, I actually create a document for the purpose of making sure I understand that requirements correctly. So here I am, I got the requirements, so I'm going to create a document that sort of like tests my requirements. And the same thing is applicable over here at the design and the architecture, and even at the low level components of my code. All right, now the whole point is that I'm doing this to make sure that I do have a good understanding of my requirements, and this is applicable in the requirements phase. Okay, now when I do get a correct understanding of my requirements, okay, and I created a test for it, then when the code is completed and by the time I get to delivery, I'll use the same test that I had over here. Okay, why waste the effort? And make sure I use those tests to test the actual system that was actually built. So when we get to the coding, we build the system, and now we're going to go ahead and test it at the customer site. Okay, so this is what we call acceptance testing. Now, again, so an acceptance test comes in the form of, I'm going to give a concrete example. Okay, and the whole point of the concrete example is to make sure that my understanding is correct. Okay, which is an ancient way of teaching, right? You've experienced this in all your math exercises and so on, where your teacher will explain something to you, and then they'll give you examples, and for the purpose of making sure that they solidify their understanding for you. Now, again, let's just say I'm the developer, you're the customer, and here you are, you're explaining to me this very sophisticated operations called the addition. Okay, but for some reason I'm just not getting it. I know it's very simple, but I'm not getting it. Okay, now you keep explaining to me this addition, that you get two numbers, you add them up together, and then gives me the total, and I'm just not getting it. But I think I have a clue. So what I do is I start to create tests for the purpose of making sure that I understand it correctly, these requirements. So I'll say, okay, So this addition functionality that you're talking about, you know, if I give it a 4 and a 5, is the result a 9? And you'll say something like yes. Okay, if I give it a 10 and a 15, was it going to give me 25? Right? And when you concur and you say this is exactly what it should be producing, then I'll say, okay, well then what I thought I understood about the requirements is then actually correct. Okay, and we can then move on with the development, knowing that we did get the requirements understood correctly. Now, later on, after we build it, okay, and we go back to the customer site and we want to test it, remember months ago when I was sitting down and saying 5 plus 4 should give me back a 9? Well, what better way to test this thing that we actually produced than by using the actual test that I had used before when I was trying to make sure that I actually understand the requirements correctly. So this 5 plus 4 equals 9 that I used before to make sure that I understand the requirements correctly, I'm going to actually use again to put it to the actual real system and see when I give it a 5 and a 4, does it actually finally give me a 9? Okay, and that's really the whole point behind acceptance testing. So acceptance testing, as you can see, it happens before and after development. So, you know, it happens before we do an acceptance testing, then it happens after. We'll focus in this lecture on what happens before. In your 4th year course, we're going to look at why we're doing it before and after. But before, okay, basically, as I said before, any concept is best understood with examples. Okay. So we want to have a common understanding of the system's black box behavior from the outside. A lot of the times when I get information from a customer, it does contain some domain assumptions, okay, due to the expertise in the domain. Okay, so you know, if I say I see a price and I say, all right, so this says 10 real, then I'm just gonna go pay 10 real. You'll say, well, of course, well then 10 real plus the 5% VAT. Okay, so that could have been a domain assumption that you made, that you said, well, the price is 10, and I thought, well, if the price is 10, I'll just pay 10. Well, it turns out no, I actually pay 10 and a little bit more because of the sales tax. Okay. A lot of times these tests show us situations that we haven't really thought of. Okay, so back to this addition example, and I'll say something like, what is 5 plus 10? You'll say 15. Okay, what if I give it a 5 and a negative 3? Okay, maybe then the customer will look back and say, well, we didn't actually think of that. Okay, what if, yeah, what if another number that we're adding itself is a negative? How should the system behave then? Okay, what if the number that we're adding has a decimal? How should it behave then? Okay, should we just round up, or how should we go about this? Okay, a lot of times we just have an issue because we want to iron out those details simply because many of the times the customer don't really know what they really want. So we kind of like we iron out, we hash it out together. Okay, but again, I'm just skimming over this topic really quickly because this will be covered in a lot more detail in your software testing course SE 412, and that's it. That will be your last lecture video of this year, and best of luck in your final exams.